Hello everyone. Note down this question. There are 3 blocks, 9 kg, 8 kg and 7 kg, and they are being pulled by a force of 48 newtons. 9, 8, 7, and the whole system is being pulled in that direction with a force of 48 newtons. Tension force in this rope is T1, tension force in this rope is T2. Find out T1 and T2 in just 20 seconds. I mean, do it fast. You don't have to draw complete free body diagrams and all. The shortcuts which we use, with the help of those shortcuts, answer T1 and T2 in just 20 seconds. Fast method. Fast method is this whole system is 7 plus 8 plus 9, 24 kg. These are massless ropes, and these massless ropes, they are just like atomic bonds between 8 and 9, 7 and 8. You can consider them like that. You have a pulling force of 48 This thing is accelerated in this direction with A, the whole side up. What is A? 48 divided by 24, 2. That's the acceleration, 2 meters per second square. Once you found A, if I ask you what is T1, for T1, group 7 and 8 together, which makes it what, 15. This is T1, tension force. Tension force is this. T2 and T2. These are the tension forces. Tension is a pulling force. You can pull, you cannot push. They are our rope. This is T1, this is T1, this is T2, this is T2. For finding T1, you must consider this much portion. The portion lying in this blue boundary only. The moment you draw a system like this, T1, these two forces, you don't have to show them, they are now internal forces. T1 is pulling something and is giving it an acceleration of A, which is 2. So what is T1? Mass into acceleration. A is 2, T1 is coming 30. And if you need T2, then consider only this much. Portion inside the red boundary, only this much. If you consider only this much, then you have 7 kg being pulled in this direction with a force of T2, producing an acceleration of 8. On 7 kg only T2 is present. So what is the value of T2? Mass into acceleration 14. एक्सेलरेशन निकालो, इन दोनों को पकड़ो, T1 मिल जाएगा, इसको पकड़ो, T2 मिल जाएगा. Note down this. Those of you who have seen Sunday's lecture, write down yes in the comment box. And if anyone was not present, then you can mention the reason behind your absence. Now write down pulley based questions. Look here. It's a frictionless pulley. There is a rope running over this pulley. There is no friction between rope and the pulley. It's a massless rope. Unless given rope will be always massless. If rope is massless, you know that everywhere tension force will be same. And there are two objects of mass m1 and mass m2 connected at the ends of the rope. I hope you can see the whole setup. This is the rope. It's a massless rope running over the frictionless pulley, having two masses m1 and m2 at these two ends. And we have been given that m1 is greater than m2. This one is heavy. If this one is heavy, you can all feel it, that it will go down with an acceleration of a, and this one is going to go up with an acceleration of a. Our aim is to find acceleration and tension force which is present in the rope. You need to find A and the tension which is present in the rope. I'm giving you 1 minute's time. Let's see if you can answer for A. Get me the value of A. We'll calculate T later on. Try to find A with whatever knowledge I have given you about rope, tension force, and use of F equals to ma. Only these things are required. F equals to ma. In a massless rope, tension is same everywhere. Tension acts away from the body. Only these things are required and you can answer this. And the other end is you need to draw free body diagrams of M1 and M2. If you will draw the free body diagrams, you can find acceleration. And the last hint, if you call it hint, these things are moving because of their weights. That hint was included in this. Once you say M1 is greater than M2, that means this is the heavier block. Heavy means what? Weight. Weight arises because of gravity. So, considering all this, you can answer A in just 1 minute's time. Let's see who will get the value of A. Look here. Let's draw the free body diagrams and all. Well, I am drawing all these free body diagrams in this figure only. Downward force mg, m1g, downward force m2g, tension which is acting on m1 is acting in this direction T, away from the body. It's a pulling force. Tension on M2 in a massless rope, tension everywhere is same. This is also T. These are the free body diagrams. In the free body diagram, you need to show all the forces and their accelerations. All the forces and their accelerations. Those of you who have drawn forces and accelerations like this, write down yes in the comment box. If you have shown T up, same tension like this, M1G, M2G, then write down yes in the comment box. This is about free body diagram. Now, for M1, mention this in the comment box. For M1, should I write T minus M1G or M1G minus T? What should I take? T minus M1G or M1G minus T? What is that which I should choose? And this will help you always in deciding these things. And it's same everywhere. You are dealing with normal reaction, tension or any other type of force. Always remember Which one is the dominating force? And why is it dominating? Because M1 is coming down. And therefore, forget about this. Take this. M1G minus T is M1A. जो ज्यादा है उसमें से कम को subtract कर दो. That will give you what? Net force. And net force is mass into acceleration. This is your equation number 1. For M2, those who did not answer the previous one between this, they should answer this now. What should I use? T minus M2G or M2G minus T. Which version should I use for M2? It should be T minus M2G or M2G minus T. Hopefully you have answered this. Now, this M2 is going up and therefore this is larger force. If this is larger, then don't go for this. Body is going up. What is net force? This minus this, which is M2 into A. That's your second equation. Equation number 1 and equation number 2. Now, you've got two equations. You've got two equations and two unknowns. There are two unknowns, T and A. And there are two equations. Everybody can solve these two equations. For A, simply do this. Equation number 1 plus equation number 2. If you go for 1 plus 2, look at this, minus T. Look at this, T. So when you add these two, T minus T, they're gone. What is on the left side? M1G. You can place these equations one on top of other and then you can add, or simply add these numbers, M1G minus M2G. So your left side is M1G minus M2G and the right side is what? M1A M2A. M1A M2A, giving you acceleration as M1 minus M2 G whole divided by M1 plus M2. For this type of pulley system, you can remember this thing as a result for objective questions. For subjective, you can see the approach. Develop equation number 1, develop equation number 2, add those equations, you will get A. And for objective profiles, you can simply write, remember what? M1 minus M2G all divided by M1 plus M2. Note down this. You've got the value of A. Put this value of A in any one of these equations and get me the value of tension force. You've got 1 minute's time. Note down everything and find out T. Well, you are again asking the same thing. This A and this A, these are the magnitudes. This A and this A. If this is 5, then this is also 5. We are dealing with magnitudes. If you want to write these equations in vector form means up is positive, down is negative, then again you will get the same result. Look, one of you is asking that A is down, if it is negative, A up should be positive, things like these. And something like this we discussed in the previous lecture also. Let me explain the whole thing again. Let's write down the equations in terms of unit vectors. T. What is net force? T. What is the direction? J cap. अब आपको ये नहीं सोचना है कि कौन ज्यादा है कौन कम है. अब आपके लिए क्या है? Up is what? J cap. N2G. N2G. What is the direction? Minus of J cap. Whole thing is what? Mass into acceleration. कितना है? A. किधर है? Up. What is up? J cap. अगर आप vectorially handle करना चाहते हैं, then this is the equation. J cap, J cap, J cap cancelled. You arrive at the same result. Similarly for this. कौन ज्यादा है कौन कम है doesn't matter. T up, write down T J cap. मैं intentionally T के नीचे T को मैनेज कर रहा हूं जिससे कि आप चीजों को समझ पाए. T is up, J cap. M1G down, M1G minus of J cap is equal to mass into acceleration. What is A? Acceleration A. किधर? Down minus of J cap. Remove J cap and then multiply the whole thing with a negative number, minus 1. M1 minus becomes M1G plus T minus plus. इसीलिए मैंने क्या बोला, एक बार हमने डिसाइड कर लिया कि ये नीचे जा रहा है dominating, instead of writing vector equation and then removing J cap and then multiplying the whole thing with negative sign, wasting time, we will from now onwards will write equations like this. Net force, hopefully समझ में आ गया होगा. Only one of you got the value of T correct. वो आपकी टेंशन है, इस A को यहां पुट कर देना. Now when you put this A in any of these equation 1 or 2, then the value of t you will get is this 2 m1 m2 g divided by m1 plus m2. Another result for this type of Pulley system. What is T? 2m1 m2g divided by m1 plus m2. What is A? m1 minus m2g whole divided by m1 plus m2. Put on this also as a result. It's not difficult. Put the value of A, simplify, and you will get it. Some of you already got this thing. Write down the next question. Find out force acting on the pulley. Find out force acting on the pulley coming from the rope. How much force is acting on the pulley which is coming from the rope? इसको समझने के लिए क्या देखना, भाई जो रोप है इसके साथ कौन कनेक्टेड है? M1 एंड M2. और ये रोप इस पूरी चीज को कहाँ खींच रही है? नीचे. रोप के साथ क्या कनेक्टेड है? M1 M2. Force on the pulley is M1 plus M2 multiplied by G. आपने एक रोप को पकड़ा हुआ है और उस रोप के साथ क्या कनेक्टेड है? एक M1 और दूसरा M2. We पूछता what is force on the pulley coming from this massless rope. आपका आंसर क्या होता? M1 plus M2 G. Do you understand this? Yes or no? Well, only one person said no, and he is correct. This is wrong. It's not correct. So you will write like this and then make a cross. Most of you simply said yes as usual. Sabne pucha yes or no? Yes. But this is no. This is not correct. Force acting on the pulley is not M1 plus M2G. Why not? इसको समझने के लिए let's take help from this. Now, look here. Suppose I ask you to hold this ball, with the help of a rope. This rope has no mass, M. Then how much force my hand is exerting to keep this ball at rest? Listen again, rest. The answer will be mg. अर्थ से नीचे खींच रही है mg से, और मेरा हाथ इस पर ऊपर कुछ फोर्स लगा रहा है जिसकी वजह से ये रुकी हुई है. Now imagine this. If I hold this ball in such a manner that it is coming down slowly. Look again, if it is coming down, ball, then my hand is not exerting a force whose magnitude is equal to mg. Had it been mg, the force coming from my hand, then this ball cannot move. अगर मैं आप इसको इस तरह से हैंडल करने के लिए बोलूं कि this thing is slipping down, or just imagine this. If I ask you to lift something which is very heavy, just assume you have a cylinder, just imaginary cylinder, very heavy. If I ask you to hold it and lift it up, the problem is that when you lift it, it is sliding down because it's very heavy. So would you say that you are exerting a force which is equal to the weight of the cylinder? I hope you will not. Why? Because that cylinder, suppose this is the cylinder I am holding in my hand. If it's very heavy and I'm not able to hold it like this, then it is slipping down. As it slips down, it means I am not providing enough force. तो अगर मेरे हाथ से sufficient force नहीं आ रहा है तो ये सिलेंडर कहाँ खिसकता हुआ चला जाएगा? नीचे, because it's heavy. इस सिचुएशन में now अब मेरा हाथ कितना फोर्स लगा रहा है इस पर? अर्थ ने नीचे लगाया mg, मैंने इसको नीचे नहीं जाने दिया, इसका मतलब मेरे हाथ ने भी कितना फोर्स लगाया? mg. बट अगर मेरे हाथ में होने के बाद ये चीज स्लिप हो रही है, इसका मतलब मैं सफिशिएंट फोर्स नहीं लगा पा रहा हूं, एंड देयरफॉर अगर चीज मूव कर रही है तो फिर an answer like this is not acceptable. Now when will you have something like this? उसको भी देखना. सपोज किसी ने आपसे बोला होता कि एक काम करो भाई, ये लो पुली, इन दोनों ब्लॉक्स को यहां लटका दो, M1, M2, and do what? इस चीज को यहां पर फेविक्विक लगाकर, फेविकॉल लगाकर चिपका दो, so that it doesn't move. If somehow you produce what? A equals to 0. With the help of a glue, you did what? you make sure that M1 and M2 they are not moving. इस कंडीशन में ये रोप कितना फोर्स इस पुली पर लगाती? आंसर विल बी M1 plus M2G. Now tell me this, क्या आपको यहां तक की बात समझ में आ गई है? Yes or no? Now write down this fast in the comment box. ये जो मैंने बॉटल की हेल्प से, रोप की हेल्प से, इस ग्लू की हेल्प से जो चीजें समझाई हैं, if you are comfortable with this, then write down yes in the comment box. तो फिर भाई अब इस क्वेश्चन का आंसर कैसे दें? इस क्वेश्चन का आंसर ऐसे देंगे, टेंशन लगती कहां है? अवे फ्रॉम द बॉडी. कौन है बॉडी? इस बार बॉडी है पुली. टेंशन लगती कहां है? अवे फ्रॉम द बॉडी. इन अ massless rope, tension everywhere is same. T. In a massless rope, tension everywhere is same. T. कहां लगती है? Away from the body. तो अगर किसी ने आपसे बोला होगा कि free body diagram of the pulley, और केवल रोप वाला, हमें इससे मतलब नहीं कि ऊपर से भी कुछ फोर्स आ रहा होगा एंड ऑल, वी नॉट इनटू दैट. ये जो पुली है, इस पर ये रोप इस तरह से फोर्स लगा रही है. अगेन, ये जो रोप है, look at this rope and this is your pulley. I hope you can see the marker. This is the pulley. यहां पर एक मास है M1, यहां एक मास M2 है. तो ये जो रोप है, I hope you can see the thing or not. If you can see the rope, ये जो फोर्स लग रहा है नीचे की तरफ, this is coming from both sides, this side as well as from this side. This is shown here. This force is what T. This force is what T. So what is the force on the pulley? T plus T, which is 2T. And what is the value of T? And therefore, answer is 4 times M1 M2G divided by M1 plus M2. That's how you answer questions like these. आपसे बोला गया फोर्स बताओ पुली पर, पुली का फ्री बॉडी डायग्राम ड्रॉ कर दो, and you can answer in just one line. Note down this. I hope चीजें क्लियर हो गई होंगी. Note down this fast. Which part do you want me to explain again? One of you is asking that force should be T plus mg. No. देखना. Let me explain the T and mg part first. थोड़ी देर के लिए आपसे बोला गया एक रोप और एक मास m और एक कोई सपोर्ट है, आपका हाथ है इस तरह से ये somebody is holding the block like this. तो अगर मैंने आपसे and as you can see that this m cannot move, नीचे की तरफ क्या फोर्स लगा mg. Everybody can see that this m is at rest. टेंशन कहाँ लगेगा? टेंशन कहाँ लगेगा? अवे. If I ask you, what is force on my hand? Is it T or is it T plus mg? What do you think? Answer this in the comment box. It's for everyone. It's for everyone because the question is good and will clear all the doubts and all if somebody is having those sort of doubts. My hand is under what tension force? Is under what force? T or T plus mg? What do you think is the correct answer? Good. The answer is what? T. Some of you have answered mg, which is also correct, but it's not T plus mg. The thing is, if you talk about m, इस m पर एक फोर्स ऊपर लगा T और एक फोर्स नीचे लगा mg. इस T से मतलब नहीं है अगर इस m की बात करोगे. तो अगर केवल इस m की बात करते आप तो केवल इतना पोर्शन देखना है. And this tells you what? ये जो m है इस पर नीचे क्या लगा mg, ऊपर क्या लगा t. क्या ये मूव कर रहा है? नहीं. If it is not moving, then this t is balancing what mg. इस सेटअप में आप आंसर क्या देते? t कितना है? mg. अब जो मैंने आपसे क्वेश्चन पूछा था कि भाई इस सपोर्ट पर ये जो आपका हाथ है इस पर कितना फोर्स लग रहा है, तो अगर आप केवल इतने पोर्शन को देखना चाहते हो तो इस पर कितना फोर्स लग रहा है? t. ये वाला T कहां लगा? इस m पर. ये mg कहां लगा? इस m पर. इस हाथ पर कितना फोर्स लगा? Only this. Now you have decided that you have calculated that this T is what mg. इसलिए आपको पता है कि आपके हाथ पर कितना फोर्स लग रहा है? mg. If someone says that force on the hand is instead T plus mg. If you took this mg as well as this T, then basically you are saying that mg plus mg, a force of 2 mg is acting, which is not correct. Which is not correct. Why? If I say that I am holding this block of 5 kg, if I am holding this with the help of a massless rope, और अगर आपने बोला कि हाथ पर कितना फोर्स लगा? एक तो ये वाला mg और एक ये t, दोनों को आपने ऐड कर दिया, t कितना मिल गया mg, टोटल क्या आ रहा है 2 mg। इसका मतलब तो क्या हो जाएगा कि 5 kg का ऑब्जेक्ट मैंने हाथ में पकड़ा है और आप बोल रहे हो कि मुझे कितना फोर्स फील करना है 10 kg के बराबर। Is it possible? No, because I am holding only what 5 kg at rest. So I hope you understand why force is not T plus mg. Don't forget to make this cross. And then one of you is asking, again explain the same thing, that in this setup y is not, yf is not m1 plus m2. सेम यहीं से चीज निकल कर आ रही है कि अगर मैं इसको यहां होल्ड करता हूं तब जाकर जो मेरे हाथ से लगने वाला फोर्स है वो किसे संभाल रहा है, इसको। बट अगर I'm giving you the same answer because there is no other way of explaining this thing. So make sure then, and in fact I explained this thing with the help of 2-3 different methods, bordle and all, everything, cylinder. So make sure that you pay proper attention also. And if you are asking because of some technical problem, because you could not listen to the voice and all, then you can always request for the recording. So the person is asking that why didn't we take total force as m1 plus m2? किस तरह से मैंने एक्सप्लेन किया था, आई एम होल्डिंग दिस, अब मेरा हाथ कितना फोर्स लगा रहा है इस बॉडी के वेट के इक्वल, ये रहा उसका रीजन। अगर ये चीज स्लिप कर रही है नीचे, if this thing is coming down, if this is slipping down, इसका मतलब जो फोर्स मैं लगा रहा हूं वो इस बॉडी को रेस्ट पर रखने के लिए सफिशिएंट नहीं है। Look here. Imagine this. This is the rope connected to this block, and this time what we did, we found that this M is slipping down. If it is slipping down, let's say with an acceleration A, what is tension force? T. What is tension force? T. What is downward force? mg. यहां से यहां पर चेंज है, इस बार ये चीज धीरे धीरे क्या हो रही है, स्लिप हो रही है। somebody is holding it but is not able to hold it, और ये नीचे स्लिप हो रही है with acceleration A. What is tension force in the rope or force on the hand by the rope or force on the rope by the hand? हर चीज का मतलब क्या है, सेम, एक्शन एंड रिएक्शन। कितना है टेंशन फोर्स, ये पूछता कोई, या कोई पूछता कि रोप ने आपके हाथ पर कितना फोर्स लगाया, या कोई ये पूछता कि आपके हाथ ने रोप पर कितना फोर्स लगाया। दे ऑल आर व्हाट, सेम। रोप ने हाथ पर क्या लगाया, टी, एक्शन। हाथ ने भी रोप पर क्या लगाया होगा, टी। क्या वो mg होगा? नहीं, इस बार नहीं होगा। क्यों नहीं होगा? लेट्स राइट डाउन द इक्वेशन फॉर m. This m, its free body diagram is this much. M is coming down with an acceleration of a, and therefore equation is this: mg minus t is equal to m into a. mg minus t equals to ma. What's the value of t? Look carefully. What's the value of t coming? T is coming T is coming mg minus ma. यहां कितना आ रहा था T? mg. यहां कितना आ रहा है T? mg से कम, mg minus ma. So if things are slipping down, then this force for a single rope setup like this is not mg. अब हमारे क्वेश्चन में क्या था? हमारे क्वेश्चन में ये पुली थी. अगर किसी ने इस पुली पर इस रोप को यहां से यहां तक फिक्स कर दिया होता, किसी तरह से आपने क्या किया, आपने इस रोप को यहां पर इस तरह से वेल्ड कर दिया, काइंड ऑफ that this m1 and this m2 they cannot move. तो अगर ऐसा हो रहा है, अगर ऐसा हो रहा है, let's try this thing. अगर इस तरह की सिचुएशन है, suppose you've got two blocks और थोड़ी देर के लिए if you look, because of friction and all things are difficult to explain, but I hope ये दिख रहा है आपको. If I release this thing, you can see that marker is coming down and the ball is going up. But what I'm asking you is, if somehow you stop them moving, the stop finger stopping the both blocks from moving, which is kind of gluing the thing. अब आपसे कोई पूछता कि इस हाथ ने या इस पुली ने कितना फोर्स लगाया, तो आंसर क्या होता? m1 प्लस m2g. लेकिन अगर ये फ्री है मूव करने के लिए, then in that case जो फोर्स होगा that will not be m1 plus m2g. Do you guys understand this thing now? Let's go for a shortcut as far as acceleration part is concerned. अपने से इस सेटअप का अगर कोई एक्सेलरेशन पूछता तो अपन क्या करते? In just one line. अभी तो हमने क्या किया था? We developed two equations by drawing free body diagrams for m1 and m2 separately. लेकिन ये जो ब्लॉक एंड पुली सिस्टम है, इसको अगर आप देखोगे then it is under two forces m1g and m2g. Now tell me this m1g and m2g, they are acting in the same direction. Just throw the logical सा क्वेश्चन है, सोचना और आंसर देना. अगर ये m1g और m2g इस तरह से लग रहे हैं in the same direction, then they are supporting each other for the acceleration, they are basically opposing each other as far as acceleration is concerned. What is your opinion? What do you think? This m1g is being opposed by m2g in producing acceleration, or m1g is getting a supportive push from m2g? You should answer in the form of support or the oppose. These are the two versions. What is the role of m2g? Is it supporting? Then write down support. If it is opposing m1g, then write down oppose in the comment box. It will give me an idea the way you feel, the way you visualize all these questions. Good. They are opposing each other as far as acceleration is concerned. अगर दोनों का मास सेम हो जाए, थोड़ी देर के लिए will take help of friction. अगर दोनों का मास सेम हो जाता तो ये m1g और ये m2g अगर इक्वल मास के होते और मैं आपसे पूछता कि भाई ये कहाँ जाएगा, तो हर आदमी बोलता कि यार कहीं नहीं जाएगा, which is also correct. अगर ये हैवी है तो ये कहाँ जाएगा, नीचे. अगर बॉल हैवी है तो कहाँ जाएगी, ये नीचे जाएगी. But if they are both are of same masses, then nothing is going to move. If nothing is going to move, then m1g and m2g, they are opposing each other. And if they are opposing each other, then this whole figure is nothing but this. A force of m1g is pulling it in this direction. This is m2 being opposed by m2g. Tension force T, and system is moving with the help of acceleration A. This is equivalent to this. It's not equal to this, it's equivalent to this. ये m1g और ये m2g, इस सेटअप में आपको लग रहा है कि दोनों का डायरेक्शन क्या है, सेम. लेकिन अगर आप रोप को कंसीडर करो तो क्या हुआ, इस m1g को ये m2g अपोज कर रहा है, लाइक दिस. अब फिर से इस सेटअप में आपको दिख रहा है कि A is coming down, this m1 is coming down and m2 is going up. It seems they are moving in different directions, which they are definitely. लेकिन ये पूरा सिस्टम किसके इक्विवेलेंट है, लाइक दिस. इसका क्या मतलब है, दोनों का डायरेक्शन क्या है, सेम. दोनों का डायरेक्शन सेम का मतलब ये दोनों along the length of rope क्या कर रहे हैं, move along the length. Look carefully. Accelerations are opposite, but in the equivalent version, m1 and m2, they both are moving along the length of the rope. What is along the length? उसको यहां से देखना. ये सामने वाले आदमी को, आपको अभी दिख रहा है कि ये मार्कर जा रहा है नीचे और बॉल जा रही है ऊपर. बिल्कुल ऐसा ही हो रहा है. दे आर मूविंग इन ऑपोजिट डायरेक्शंस. लेकिन लेंथ वाइज बात करें तो ये चीज ऐसे हो रही है, पूरा का पूरा सिस्टम इधर आ रहा है. ट्राई टू विजुअलाइज कि पूरा का पूरा सिस्टम ऐसे आ रहा है, which means a system like this can be converted into a system like this. What is the advantage? अब यहां एडवांटेज ये है कि आपने बोला कि एक काम करते हैं, M1 और M2 दोनों को एक साथ देखते हैं. Consider M1 and M2 together. And the moment you consider M1 and M2 together, I want you to write one equation F equals to ma, and the moment you get same acceleration M1 minus M2 g upon M1 plus M2, write down yes in the comment box. Let's see who can find that equation again. Take them together. This is M1g, this is M2g. जैसे ही आप M1 M2 को एक साथ देखोगे, T, it becomes an internal force. And if T becomes internal, M1G, M2G, अपने को पता है M1G ज्यादा था, ये इधर जा रहा है. What is net force? M1G minus M2G. And what is net force? Total mass. Why did we take M1 and M2 both? ये लिखा है दोनों को एक साथ. T क्यों नहीं लिया? Internal है, किसी काम का नहीं. Multiplied by A, and in one line, in just one line, you get your A as M1 minus M2 G divided by M1 plus M2. इतना इजी है A फाइंड करना, इस A को याद रखना. What is A? This minus this, net force. और ये net force किसे खींच रहा है? इस पूरे मास को, M1 and M2.